Alright, in this section, 12.2, we talk about exponential functions. Chapter 12 talks about both exponential and logarithmic functions. We won't handle logarithmic in this class. Alright, so they talk about an interesting idea. It says, if you deposit money into a savings account, you might earn an interest rate of 0.18%, less than 1%. Whereas if you charge purchases on your credit card, you might pay an interest rate of 18%. Do interest rates and decimals really matter? Well, to find out, let's consider the following. If $1,000 is deposited into a savings account at 0.18% interest per year for 15 years, final amount is $1,027.37. So you only get 27 bucks back for keeping your money there for 15 years. Not much. However, if the interest rate were a typical credit card rate of 18%, the final amount would be about $14,584.37. So $1,000 charged 15 years later is $14,000, whereas $1,000 in the savings account is only $1,027. So 0.18% is a huge difference from 18%. So the decimal and the percentage interest do matter. All right. So first thing they talk about in this section is they talk about insects on a acre of land. So if they say if you start out with an acre of land and you know that you have 100 insects on the land, that acre, after 1 week the number of insects, the insect population will double to 200, and each week it will double each week. So 200 after 1 week, 400 after 2 weeks, 800, 1600, 3200 after 5 weeks. And so the amount is doubling every week, and it just grows incredibly fast. Now the formula that they're using there is f of x equals 100 times 2 to the x. The x is in the exponent there. That's why it's called an exponential function. So when you plug a 0 in there for the exponent, you get 100 times 2 to the 0, which is 100 times 1, or 100. Plug a 1 in there, you get 100 times 2 to the 1, which is 100 times 2, or 200. Plug a 2 into the exponent, you get 100 times 2 to the second, which is 100 times 4, or 400. And so you can find out what any given value is just by plugging it into the function. Now you've got two different types of exponential functions. Exponential growth, which looks like this, it goes up from left to right. Then exponential decay, which looks like this, and it goes down from left to right. And this is typically when something is disappearing before your eyes. It's called half-life of something, becomes less and less and less of the object as you go along. All right. So the first thing they do is they talk about some given functions here. And they say exponent 1, or example 1, they say f of x equals 10 times 3 to the x. What is f of 2? So you plug a 2 in there for x, and so you have to square the 3, and you get 9. 9 times 10 is 100. But you can also just type it into your calculator. You can type in 10 times 3 hat 2. 10 times 3 to the second. And then 5 times 1/2 to the x, where you're plugging in a 3, it's 5 times 1/2 to the third. So 5, and now to do the 1/2, you got to put in parentheses. Parentheses 1 divide 2, close parentheses, hat 3. And you'll get a decimal, but just hit math 1, enter, and you get the nice fraction of 5 over 8. Then 1/3 times 2 to the x, where x is -1, so it's 1/3 times 2 to the -1. Well, you're going to have to put the 1/3 in parentheses and type in 1 divide 3. 1 divide 3, close parentheses, times 2 hat -1. Okay, and you get that number there, but if you hit math 1, enter, you get 1 over 6. Alright, now they ask you to compare 3 to the x versus 3x. Okay, so if you type in 3 hat x, and you type in 3x, and you hit zoom 6. This first one is 3 to the x. The second one is 3x. So if you notice, 3 to the x grows incredibly fast. It grows up so fast you can't even see it anymore, whereas 3 to the x goes up slowly. Okay, so 3 to the x is a lot bigger than 3x. So linear growth is not as nice as exponential growth is. Okay. example 3. Example 3, they give you a bunch of tables here, and they ask you to identify if they're exponential growth or logarithmic. Alright? So when you look at A here, you see these go up by 1, up by 1, up by 1. These go down by 8, down by 4, down by 2. It's definitely not linear, so it's exponential. Now how do you find the exponential function? Well, remember your exponential function is f of x equals c times some number a to the x. C is your starting amount and a is what's called your growth factor. So to find what c is, you just look at where x equals 0. So c has to be 16 here. Okay. Now, if you use c equals 16 and you also take another point, a simpler point is always best, so pick 118 is the best one here. So let's use the point 18 and we're going to use c equals 16. And we take the equation, instead of f of x we write y, same thing, right? So in place of y you put a 8, in place of c you put a 16, in place of x you put a 1. And so that's 16 times a to the 1, or 16a, equals 8. And you divide by 16 and you get a equals 1/2. And so there's your formula. Remember, it's c times a to the x. Well, c is 16, a is 1/2. So there's your formula. Now b, it asks, is this linear or exponential? Well, it's going up by 2, up by 2, up by 2. That's linear. Okay? And when x is 0, that's your b, so your b is 5. And if you're going up by 2 as you go up by 1, that's 2 over 1 is your slope. So your slope is 2, your y-intercept is 5, so 2x plus 5. Now c, you go up by 3, up by 6, up by 18, up by 54. This one is not linear. This is exponential. So 0, 1 will tell you what c is. C has to be 1. And use the point 13. So exponential c is 1. Using the point 13, we're going to plug in 1 for x and 3 for y. So 3 for y, 1 for x, 1 for c. And you get 3 equals a. So a has to be 3. Remember, this is c times a to the x, or 1 times 3 to the x. C is 1, a is 3. And so there you go. You found this guy here. Alright. Now in example 4, they give you a question and they say, find the percentage change if an account balance increases from 500 to 1,000. Well, the book gives you this formula, b minus a over a times 100%. They actually don't put the percentage sign after it. They just say times 100, but I like to write the percentage symbol after that. An easier way is to remember new minus old over old. Right? So your new amount is 1,000, your old amount is 500, so new minus old is 1,000 minus 500 over the old of 500 times 100%. Well, that's 500 over 500, which is just 1. 1 times 100 is 100%. Now they say, what's the percentage change if it decreases from 1,000 to 500? So your new amount is 500, your old amount is 1,000. So 500 minus 1,000 over 1,000 times 100%. That's minus 500 over 1,000, or minus 1/2, times 100 is minus 50%. Notice this one's positive and that one's negative. The sign is very important there. Make sure you get the right sign on that one. All right. Now it says analyze the decrease in an account balance. An account contains $2,000 and it decreases by 20%. So $2,000 decreases by 20%. 20% is 0.20 and it's negative because it's decreasing, so it decreases by $400. Now they ask you how much is in the account now. Well, subtract 400 from the original amount and you get 1,600. Now they ask you what factor A did the account decrease. Well, your growth factor is always 1 plus R. Since your R is negative 0.20, it's 1 plus negative 0.20, or 0.80, or 80% growth rate. Okay. Number 6, they talk about the amount of bacteria. They say a lab culture contains 50,000 bacteria per milliliter, and it's increasing at 20% per hour. Write a formula, function B, that represents the number of bacteria per milliliter after X hours. So you get B of X equals C times A to the X. Now you got to figure out what C and A are. Well, if you're starting out with 50,000, your C is 50,000. Your R is 0.20, so A is 1 plus R, or 1 plus 0.20, or 1.20. So now you know your C is 50,000, your A is 1.20. You got your formula. Now it says evaluate B of 3, so you're just plugging in a 3 in there for X, and you multiply it out, and you get 86,400. What that means is, after 3 hours later, your 50,000 bacteria have grown to 86,400 bacteria. It's growing very fast. Okay. Number 7, calculating compound interest. Now, there's two different formulas for compound interest. Now, if they don't tell you that it's compounding, if they don't tell you what the compounding is, you just leave it with this formula here. A equals P, 1 plus R to the T. P is your starting amount, A is your ending amount, R is your interest rate, T is the number of years. Now, this person's 20 and they turn 65, so T is 45. They start out with $2,000 and it grows at 6%. And so you get 2,000, 1 plus 0.06 raised to the 45. And so you can do all that in your calculator. You just type that in just the way you see it. You type in 2,000, 1 plus 0.20, or, excuse me, 0.06, parentheses, hat, 45. And you get this number here. And you want to round it to 2 decimals because it's money. Now they ask you what's the growth factor. It's always 1 plus R. Well, you know R is 0.06, so 1 plus 0.06 is 1.06. And number 8, now they talk about compounded monthly. Because they talk about the compounding, you have to use this formula now. It has a new variable called N. N is how many compoundings in a year. Alright, so your P is your starting amount, R is your interest rate, T is time, nothing's changed there. Time is always in years, by the way. N is how many compoundings in a year. Well, if it's compounded monthly, how many months in a year? 12. So you just plug in all these numbers in here, and you can figure that guy out. You can just type it the way you see it. 1,500, parentheses, 1 plus 0.06 divided by 12, parentheses, hat, 12 times 5. And you get 2023.28 when you round it to 2 places. Okay. Number 9, it says in September of 2008, 100 million iPhone applications were downloaded. And the number of iPhone downloads was increasing at a rate of 28.4% per month. What is the monthly growth factor? Well, your growth factor is always 1 plus R. And since R is 28.4, it's 0.284 plus 1 is 1.284. B says write the formula. Well, we know the A is 1.284, and we know it starts out at 100, so C has to be 100. So it's 100, 1.284 to the X. Now they just say evaluate P of 12 and interpret the results. So you plug 12 in there and you multiply that out, and you get 2008 point something. So roughly 2008 million, from 100 million to 2008 million, or roughly 2 billion, which is a huge increase over 1 year. Okay. Now, number 10 is kind of an unusual question. Number 10, what they give you here is this is a function dealing with traffic. It says on average a particular intersection has 360 vehicles arriving randomly every hour. Traffic engineers use the function 0.905 to the X to estimate the likelihood or probability that no vehicle will enter the intersection within an interval of X seconds, meaning that no vehicle enters the intersection. Alright, and so if you look at this, you got, when X equals 0, you got 1.00, or 100% probability that no vehicle has entered the intersection. That makes sense because there's no time has gone by. Now after 5 seconds, you have 6.6 or 0.60, which is 60% probability that no vehicle has entered the intersection. And as you go further along in time, the probability that no vehicle has entered the intersection is dropping because as time goes by, you're expecting a vehicle at some point to come along. All right? And so f of 5 is just plugging in 5 for x, and you multiply it out, and you convert it to a percentage. And we showed that as time increases, the probability is going to drop. And they ask you, what kind of a graph is this? Well, it's exponential decay because it's getting smaller from left to right. Now, number 11 talks about Texas population. It says you have a population of 26 million and it's growing at 2% continuously. So it's 26e to the 0.02x. Now they ask you to estimate what happens 4 years later, so you're plugging a 4 in there for x. And the way you type this guy in, you type in 26, and now how do you get the e? You hit second divide. Second divide will get you the e. Then you hit the hat key, 0.02 times 4. And you get 28.165 or 28.2 million. So 26, second divide, hat, and type in your exponent there. That's how you get that guy. So what have we talked about so far? An exponential function sometimes has a constant in front we call c, and that's your initial value or your starting amount. A is your growth factor, it's 1 plus r, and it's typically raised to a value x. And you have exponential growth and exponential decay. Now you've got percentage change is new minus old over old times 100%. Okay, and we talked about the exponential growth factor. If it's constant percentage change, you can just do c times a to the x. A is just 1 plus r. Now with compound interest, it depends on if they're compounded annually or compounded more than annually. Annually, you just use p 1 plus r to the t. More than annually, you got to use this more complicated formula. And finally, the last thing they mention is e to the x. F of x equals e to the x. That's the very last one that we did there. So if we look at the problems in this section, the similar questions, the first question, first several questions, they're just plugging in values into the function. So they're plugging in a negative 2 in for x, so negative 2 into the exponent, so you got to figure out what 3 to the negative 2 is. 3 hat negative 2. And you could hit math 1, enter, and it breaks it down to 1/9. And you can do 3 to the positive 2. 3 hat 2 is 9. And then here you can do 5 times 2 to the x, 5 times 2 to the 0, and I did it by hand, but you can also do it on your calculator. And 5 times 2 to the 5th, you can do that by hand or by your calculator. And then 15, 1/2 to the x, and they ask you to plug in a negative 2 there. You want to put the 1/2 in parentheses. Parentheses 1 divide 2, close parentheses, hat negative 2. And you get 4. And then 1/2 to the 3rd, parentheses 1 divide 2, close parentheses, hat 3. And remember to convert it to a fraction by hitting math 1, enter, and you get 1/8. Okay, number 17, you're plugging in a negative number, but notice you got negative x there, so it's negative 1, which is really positive 1. So you want to watch your signs there. Then 5 times 3 to the negative 2, because the exponent is already negative there, and you're plugging in a 2, so it's negative 2. And then negative 3 here into this one, 1.8 to the negative 3. And I did it by hand, but you can also do it on your calculator. And 1.8 raised to the 1.5 as well. And this one's 3 times 0.6 to the x, and you're plugging in a negative 1, or you're plugging in a positive 2. Okay, now here, number 45, they ask you what kind of growth is this. Well, if you look at this, you're subtracting 48, you're subtracting 8, you're subtracting 3, you're subtracting 3/4. This is not linear. And it's exponential, and it's exponential decay because it's getting smaller and smaller. Now when you look at when x equals 0, that's your c, so you know c is 64. And we're going to use the next point after it, 116 here. That's a nice one to use. And you plug in 1 for x, 16 for y, and 64 for c, and you can figure out what c is here, right? You plug in all those numbers, and 64a to the 1 is just 64a. And then divide by 64 and reduce it, and you get a is 1/4. And now that you know a is 1/4 and c is 64, you got your equation, because that's your equation's format, right? c times a to the x, c times a to the x. Now 47, it asks you Is this linear, exponential, or what? Well, it's linear because it's going up by adding 3, adding 3, adding 3. So your equation here is 0, 8, so that means your b is 8. And if you're going up 3 as you go up 1, that's 3 over 1, so your slope is 3. So it's just 3x plus 8. Now 49, you're getting bigger and bigger and bigger, but it's getting bigger in different increments each time, so this is exponential growth because it's getting bigger. Now, how do you figure out what your numbers are? Well, if you look at where x equals 0, you got c equals 4. And you take the next point, or a point, 1, 5, and plug in 1 for x, 5 for y, and 4 for c, and you solve it, and you get a equals 5/4. So, c is 4, a is 5/4, and there's your equation right there. On this one, they ask you to use the graph to determine the constants c and a. Well, you're going to need to know a couple of points. So you got 0, 1, and you got 1, 2, and you got 2, 4. So using those 3 points and the techniques that we've done before, you can figure out what the formula is there. And here you got 0, 4, and you got 1, 1. Those are the only 2 points you have, really. But that's enough, right? 0, 4 tells you that c is 4. And using 1, 1, you can nail down that a is 1/4. And that's how you find out what the answer is. And these two, they ask you to graph it. Well, you can just type this into your calculator. You can just type in parentheses, oops, that's right, parentheses 1 divided 4, parentheses, hat x. And when you hit zoom 6, standard window, this is what your graph looks like, and so that's how you graph it. Now if you want some points, just hit second graph, and you got all these points here for you to use to graph it. And you can do the same thing with this one. You can fill in your chart and graph your points very nicely. I see there. And the same thing here with this one. And the same thing here with this one. Now when you type in this one, 2 to the x plus 1, you make sure that x plus 1, 2 to the x plus 1, make sure that x plus 1 is in the exponent. And when you type this in, make sure that this subtract 1 is not in your exponent. Okay? So you have to be careful when you type these into your calculator. Now 71, they say, suppose $1,000 is invested at 8% for 10 years. Then what about 2,000? Are you going to end up with twice as much money? Well, you figure out what 1,000 will give you, figure out what 2,000 will give you, and you see that the amount of money is doubled. So yes, it will give you double the amount that you started with. Now the question on your homework assignment will say 3 times as much, and they use the word thrice. T-H-R-I-C-E, kind of a weird word, but that means times 3. That's what that means. Alright, e to the x, you're just plugging in 1.2, and so you're figuring out what e to the 1.2 is. And you can do that by hitting second divide, get you the e, hat 1.2. And you round it however much you want to round it. And the same thing here, 1 subtract e to the, in this case, negative 2. 1 subtract, and e is second divide, hat negative 2. And you round it to however many decimals they want you to round it to. 99, they give you this formula here, and they tell you the p is 2.7 and r is 1.4% or 0.014. And so there's your formula. And then they say what happens 10 years later, so you plug 10 in there, and you get an answer that you get there. Right. Now this one's E. coli. Let me show you this one. Right. So with this E. coli, you've got this chart here, and they talk about the amount of bacteria that will grow. It starts out at 500 cultures. It's actually 500,000 cultures at time 0, and it doubles every 50 minutes. So they ask you to come up with the equation. Well, they tell you the equation is initially C times A raised to the t over 50. It's kind of a weird function. And they ask you to figure out what C and A are. Well, we know C is 500 because when t is 0, you got 500, so C is 500. And then use this point here as what, you could use any of them, but this one's the easiest one, I guess, 50, 1000. So plug in 50 for t, and 1000 for f of t, and 500 for c, and 50 over 50 is just 1, and you don't need to write the 1. And then to solve this, 1000 equals 500x divided by 500, and a is 2. So now you got your equation there, 500 times 2 to the t over 50. It's a weird question, but there you go. Okay, and this one talks about modeling traffic, and they ask you to come up with a table. And so here's your table, and after every 10 seconds of time that's gone by, the probability that no car has entered the intersection drops dramatically from 100% down to 5% to 1% to less than 1%. So they ask you what's happening, what does f of 0 equal 1 mean? Well, f of 0, that means time 0, and 1, or 1.00, means 100%. So there's a 100% chance that no car has entered the intersection because, like I said, there's no time has gone by. Now they ask you when is there only a 5% chance that no car has entered the intersection? Well, the 5% chance is right there at 0.050501. Yeah. So that's after 30 seconds at time t equals 30. And then this one, 65 and 67, they're both a equals p, 1 plus r to the x, and you just plug in your p, and you plug in your r, and you plug in your x, and you just crunch it down, round it to 2 digits. Same thing here. Round it to 2 decimal places. Now when you look at your homework assignment, everything's like we've been doing, but some of the things you want to be careful about, it's like right here on number 4, they say negative x. May not be that easy to see there, but that's 3 times 5 to the negative x, but x is negative 2, so that's negative 2 when you plug in a negative 2. So it's really negative 2 is really just positive 2. You have to be careful with your negative signs. And here you're plugging in a negative 3, here you're plugging in a negative 3. They throw a lot of negatives at you, so you got to be careful there. And now here's where they give you the table and you have to come up with the equation. You can see that this is exponential decay because it's not linear. It's not dropping at the same rate. It's dramatically different changes in between each of these values. So 0, 1024, that means c equals 1024. And use 1, 256 to plug in for x and f of x along with the 1024 here, and you'll be able to figure out what c is. Number 8, same idea, but if you look at this one, 7, 13, 19, that's linear. They're adding 6 each time, so you can figure out what the equation of that line is. Number 9, from 2 to 5 and 5 to 12.5, those are clearly not the same distance apart, so this one's exponential growth. So use 0, 2 to figure out c is 2, and then try and use maybe 1, 5 for your x and your y, and that'll allow you to figure out what a is. The fact that this is getting larger and larger means it's exponential growth. Now this one says come up with the equation using the graph here. So from this graph you can see here you got 0, 3, and you got 1, 6, it looks like. 0, 3 and 1, 6. So 0, 3 means c is 3. And using 1, 6, you can figure out what a is. And same thing here, 0, 2 means c is 2. And you can use the 0.11 to figure out what a is. Then here, 1/10 to the x, you would expect it to be going down from left to right, and you can graph that on your calculator pretty easily. Number 13, graph 2 to the negative x, and they want you to use these x and y values, so you're going to have to hit window. You're going to have to hit window and type in these values. All 3 there, all 3 there. They give you x min, x max, and x scale. Y min, y max, y scale. You have to type in all 6 numbers first. Okay. And now when they ask you to graph each one of these, you want to type these into your calculator. 2 to the x plus 2. And hit zoom 6. Zoom 6 will give you a 10 by 10 window, and just pick which one's the right one. Same thing here. Okay. Well, this is the one I was telling you about, where on the example we did one that was twice as much money. And we found that if you start out with twice as much money, you end up with twice as much money. This one they're asking if you start out with a certain amount of money and then you triple it, will you end up with triple as much money? So you're going to have to check that one out and see if you end up with triple the amount of money you started with. And then e to the x with 1.3 there. 2 subtract e to the x where x is negative 1. Plug that in properly there. And this one's p, e to the rx. P is 34. R is, since R is 2.1, you're going to use 0.021 there. and you can find the formula, and then you can calculate given the question that for part B there. And then this one's your bacteria. It's the same thing as what we did earlier. You're going to use 0, 260 for your C is 260, and use 50, 1040 for your T and your F of T, so you can nail down what A is. And here's the intersection problem, 0.905 to the x, and you don't want you to fill out these numbers, but they want you to go out to 5 decimal places, so you got to actually know what the 6th decimal place is in order to round it properly to 5. Alright? Then you plug in 25 and give them a number, again rounding out to 5 decimal places, and interpret the results there. This one here, they want you to use this formula here, and same thing here with this one. They don't ever ask you on the homework to use the other formula. They only use this one. So that's what you do there.